and thank you for joining our Faculty of Agricultural and Food Sciences Conversation series. My name is Annemieke Vernorst and I'm the Associate Dean Research of the faculty. The title of today's seminar is a made-in-Manitoba solution to monitoring stored grain. Before we start, I would like to acknowledge that the University of Manitoba is located on the original lands of the Anishinaabe, Cree, Ojibwe, Dakota, and Dene people, and on the homeland of the Métis Nation. We respect the treaties that were made on these territories, and we acknowledge the harms and mistakes of the past. We dedicate ourselves to moving forward in partnership with Indigenous communities in a spirit of reconciliation and collaboration. Today marks our 5th faculty seminar in a virtual format. And if you missed the previous seminars, there is still an opportunity to view them, for example, through our faculty's YouTube video channel. As another option, you can also find links to the seminars at our wonderful knowledge translation portal called the Manitoba Agriculture and Food Knowledge Exchange. And for your reference, you can see the website address here on your screen, makemanitoba.ca. MakeManitoba.ca highlights our faculty's research as it relates to consumers and producers, and it includes a collection of podcasts, infographics, and fact sheets, and even delicious recipes. So please check it out. Today we have 3 speakers, and they will engage with us, first of all, by a short summary of their research, and then they engage with each other as a conversation. You as viewer can also participate in this conversation by sending your questions and comments via a chat platform. Right now, I would like to call on Crystal Jurgensen, the faculty's communication specialist, to tell us more about how the audience can actually participate in today's presentation. So, Crystal, over to you.
Thanks, Annemieke. To participate in our question and answer period later on today, you'll want to visit slido.com and you'll see the URL crawling across the bottom of the screen there. When you get there, you'll enter #storedgrain. That's the event code for our event. And when you're in there, you'll come to a window where you can enter your questions and comments. Please be aware that there is a limited character count, only about 160 characters. So keep your comments and questions as brief as you can. And just to kick us off today, maybe you could tell us, where are you watching today in Manitoba or across Canada or maybe elsewhere in the world? And we'll come back to it. Thank you, Annemieke.
Thanks a lot, Crystal. Appreciate that. And perhaps we can review those instructions again when we hit the question and answer round at the end of the seminars. So today's topic explores grain storage technology, which is crucial because grains are increasingly stored for longer durations than ever before. As well, the shift of storage from grain elevators to on-farm also brings new research needs. Post-harvest grain spoilage is globally estimated at 20% and costs more than $1 billion each year to Canada alone. Hence, seeking ways to minimize such spoilage is essential. The University of Manitoba is a world leader in grain storage research, spanning more than 50 years of interdisciplinary collaborations. Specifically, the Grain Storage Research Laboratory in Biosystems Engineering is one of the few research facilities in the world that looks at post-harvest grain management in a holistic fashion. So today we will hear from a biosystem engineer, an electrical engineer, and a physicist who are using imaging methods originally developed to detect breast cancer tumors. This adopted technology has the potential to spot early signs of spoilage throughout the entire grain bin. So now, with further ado, I would like to introduce to you the today's guests. And I will start with welcoming Dr. Jitendra Paliwal, who I interact with on a daily basis as my colleague in the Dean's office. So I know him very well. Jitendra is a professor of Biosystem Engineering and the Associate Dean Academic and Graduate Programs in the Faculty of Agricultural and Food Sciences at the University of Manitoba. Jitendra's research explores the fundamental mechanisms of spoilage of agricultural commodities. In his research, he utilizes the optoelectronic properties of cereal grains, oilseeds, and leguminous crops for their quality assessment and preservation. So with that, take it away, Jitendra. Thank you.
Thank you, Anamika. Good afternoon, everyone. Before I begin, I'll just set my timer because I've been told that I have exactly 5 minutes, after which I'll be booted out. So let me start that. When Crystal approached me to give this presentation, I was told that I have to make it entertaining. And how entertaining can you make grain storage? What I decided to do was, I thought that maybe I'll just put together a slideshow, just a few slides. Can you see that? Okay, just 1 second. Right, thank you, there we go. So, to make this presentation, to make grain storage entertaining, I thought that maybe I should give it that Hollywood hype. And I would start with one problem, 2 professors, and 3 entrepreneurs. What happens next will astonish you. And that's the entertainment bit. Let's get to the more substance here. What is the problem that we're solving here? So anybody who lives in the prairies has seen that how agriculture and grain storage has changed over the years. Grain is primarily stored in big bins, and it used to be mostly at the elevator level, but now it has changed a little bit. If we were to look at the number of grain elevators over time, over the last few decades, you can see that the grain elevators have gone down substantially. So what is happening is that most of the grain is now stored at the farm level, which puts a lot of pressure on the farmers as being the primary managers of their harvest. If we were to look at what has happened over time, in 1995, the average size of the storage bin here in the Canadian prairies used to be about 6 meters. Fast forward 20 years, and we see that the grain bin diameters have doubled, which poses their own problems because the bins are so big now, you cannot really sample your stored crop. In the past, you could easily push a probe and get the sample from the sides. But now, as you can see, that you can only push these probes so far. To be able to get to the central core of the bin, it's not easy. And different technologies over time have come up, and that includes, hanging the cable systems into the bin, but that has its own challenges because it puts a lot of pressure on the roof of the bin. If once the bin is full and your sensors die out, there is really no way in a bin full of grain to get there and fix that problem. And if your grain starts to spoil, you're not going to know that. The next entertaining piece was the 2 professors. So in the engineering building, back in the day, I used to eat lunch in the faculty lounge, and I happened to meet a professor from electrical engineering, Joe Lavetri, who's in charge of the electromagnetic imaging laboratory in electrical engineering. He does primarily, or at the time used to do primarily, cancer research. So they were looking at an alternative technique to mammograms to identify or to find tumors in the breast tissue. So we started talking, and then, and this is, by the way, my picture from 2012. So Joe and I started talking. Joe said that he has a student who's working in breast imaging area, and maybe I should be on the committee. And I thought, why not? I do imaging of grain. He does imaging of biological tissue. Maybe we should get together. And so that way I was put on the PhD committee of Colin Gilmore. I also volunteered as one of his subjects to let him image my arm. So Colin and I were doing this imaging in the lab, and there were very long, awkward silences. Both of us, really not very talkative people. And then I just thought a very, stupid idea crossed my mind, and I asked Colin, can we use this technique that you're using for your thesis for grain? And as you would think, a PhD student would brush off a professor's stupid question, and that was that's how that conversation ended at the time. But later on, Colin got together with two of his buddies, Paul Card and Ian Jeffrey. Colin, by the way, is right here in the middle, and you'll get to meet him very soon. He got together with two of his buddies, and they pursued this idea and started a company called 151 Research. And at this point, my 5 minutes are up, and I will let Colin take over from here. Over to you, Colin.
Thanks, Jitendra. I'm just going to pull up my slides here. And so to carry through with Jitendra's story, I guess, I have some slides prepared to show you where we ended up, but it's hard to follow that introduction of, there's a jump of many, many years of work from 2011 to maybe 2016 before there was actually employees at the company. And I'm going to give you a status of where this imaging idea is today, rather than continuing, I guess, just the story to describe what we actually do with the bin imaging system. So in the intervening years between talking with Jitendra, I also became a professor in the Department of Electrical and Computer Engineering. And I'm currently a Tier 2 Canada Research Chair in Applied Electromagnetic Conversion. And I work almost exclusively in this grain area right now. So what the system that was kicked off by Jitendra's idea was to create a series of antennas around the outside of the bin. And this is a picture of both a schematic. So we have some electronics that sit outside of the bin, and the antennas are on the inside of the bin, but attached to the bin wall. And that's the main picture here. This is a bin of a recent installation filled with some rice. This is a picture on the bottom left of the antennas. They're about 50 centimeters tall, and they're mounted on the bin. And what we do is we transmit from one antenna, then receive on all of the other antennas in the bin. And that's what the transceiver system does that. And then it swishes the transmitter and receives on all the other antennas, and goes through the whole process so that every antenna has transmitted and they've all received for every other transmitter. So we end up with this set of data from these antennas that is stored locally, and then it's sent over the cell phone network or Wi-Fi network to cloud servers, where we make images of the grain inside the bin. And that processing, it's too big of a processing job, but that is done. So it's done to do locally. So we do it on a cloud server. And those algorithms are identical, whether we're imaging biological targets or whether we're imaging grain. It's literally the same code that we run for the grain bin imaging that we do for biological tissues. So that process is called inversion, and this isn't the place to go through the details of that. So I'm just going to show the result of the kind of image we get. So this is a hopper style bin that's in Jitendra's lab, the grain storage research lab. And what we did is we went in and basically buried a wet bag of grain in this bin. So we have a flat surface of grain, and then we use this imaging system to make an image of the grain inside. And this image is just a snapshot in time that I'm giving you, this little animation, so that you can see, it's obvious where we buried that bag of wet grain. And you can kind of see how we simulate the bin with a series of small tetrahedrals. So we end up with this kind of blocky shape, but it's very clear that you can find a wet spot in the grain, and that's starting to spoil. That's bad. The farmer or the grain handler needs to solve that problem quickly, either by flipping the bin, emptying the bin, or turning on fans, or doing some kind of management process. Otherwise, you could have the whole bin spoil. This is just another example of the kind of images we can get out of this technology. And this is just we can scan through the bin to show different types of moisture content within the bin. So this bin has the wet grain at the top, so it's wheat and up at 15% near the top of the bin. But as you scan through these different moisture contents, you can see that it's drier near the bottom of this bin. It's about 12% at the bottom, but you can actually see when and where that grain is within a certain moisture region, which is important because to maintain safe storage but maximize your profit, you want to control that moisture very carefully. So that's just a quick example of what the technology can do. But back to the story of Jitendra, the business story. So after we created this company, we got through initial sales and the initial process. And recently we attracted the interest of AGCO, which is a large multinational agricultural corporation, who eventually ended up buying 151 Research. And up next is Kurt, and Kurt is going to be talking, Kurt Hildebrand will be talking about, from the AGCO perspective now, what this technology is and how they are continuing to develop it and how it fits in with a larger view of their agricultural, how they are going to manage grain and on farm and on commercial sites.
Thank you so much, Colin, and thank you for mentioning that you are the Tier 2 Canada Research Chair in Applied Electromagnetic Inversion, and that is in the Faculty of Engineering at the University of Manitoba. And thanks for sharing some of your research interest, including that you're not only working on grain bins, but also on biological tissues and so forth. So next, I would like to welcome Kurt Hildebrand, and mentioned was already AGCO, so and I know that you are working there. So Kurt's academic background is in physics, and he studied wave propagation in complex materials. And since then, Kurt has been involved in the private sector, and he is the product development manager in advanced research at the aforementioned AGCO in Winnipeg. There, he's leading multidisciplinary research and development teams for several startup companies. And so, Kurt, the floor is yours.
All right, thank you very much. Just want to make sure you can hear me. My headphones are sounding a bit off, but if you can hear me, let me know. Great, okay, so first of all, I wasn't told to make this entertaining, so I'll have to try and work something in here. I think the funniest part was when Jitendra said that Colin wasn't very talkative. That's never been my experience so far. But I want to give you a quick look at how I fit into the GrainViz story, as well as how GrainViz fits into the sort of larger vision we have at AGCO. I joined the 151 research team about 2 years ago, partly to help bridge the gap between GrainViz radio wave imaging as a laboratory success to get to the commercially ready GrainViz product, and all the associated research and development needs there are surrounding moving from lab scale to commercial scale. For one example, like GrainViz measures the electromagnetic properties of the stored grain, specifically the permittivity of that material. And we need to do a lot of lab scale experiments to then build the model converting the permittivity measurement to the physical properties that the end users generally are interested in, such as the moisture content of the grain, the temperature, and the density. And these maps are specific to each grain type. So there's quite a lot of research to be done there. Furthermore, when I joined the team in 2019, 151 Research was already working on additional technology for monitoring grains in additional storage configurations at other critical points in the storage and handling post-harvest life cycle of the grain. My role was then to help manage the research and development of these additional technologies as well. So now, as Colin mentioned, being under the umbrella of AGCO, we have access to additional resources and development partnerships to help drive forward, additional post-harvest grain monitoring technology. Let's see here, next slide. Okay, so for some examples, GSI, who was our sort of first point of entry to AGCO, they provide grain storage, drying, and handling equipment. And Cimbria provides full-scale solutions for a wide range of grain handling applications, from food and seed processing to grain elevators and port terminals, in fact. So we're also able to work with other AGCO brands in their so-called rolling divisions, tractors and combines and things like that. So we can connect with data sources from other equipment, like harvesting equipment, for example. So I think that this AGCO acquisition provides us with an opportunity for 151 Research, which is now called AGCO Winnipeg, and an opportunity for the collaborative research that we're doing with the University of Manitoba, with Colin and Jitendra's groups, for example. So we can play a role in what I think is the next generation of agricultural technological integration. GrainViz is a revolutionary technology on its own, but I think that the impact is even more significant in the context of connected smart agriculture. So through the connection of all the data sources and control points that we will have throughout the grain product life cycle, we have the opportunity to make advances in both food traceability and in process optimization. And ultimately, this means more efficiency and less waste, as well as hopefully increased fairness for all stakeholders in the supply chain through transparency of information. So I think there's a lot of broad goals here that AGCO has in terms of where they want to take this technology. We want to work on things like, where's my next slide here? There we go. Autonomous grain handling solutions and facilities, which is a nice opportunity again for collaboration with the Grain Storage Research Lab. And we're also interested in integration of complete traceability and data connectivity from farm to fork, as they say. I'm not sure if my 5 minutes are up yet. Maybe someone will give me a little heads up there. Just to give you a little other insight about GrainViz itself. Right now, GrainViz is being targeted toward commercial elevators and sophisticated producers as our end users of the technology. In these cases, they're monitoring large capacity, high value, and high risk commodity storage, or high throughput situations where detailed inventory tracking is needed. GrainViz is not completely at the commercial launch stage just now. So, our customers so far have been part of research and development agreements, and so they're providing us with feedback and test data in order to drive out the functionality and any errors that might crop up with the system and with the imaging. But we're hoping to, I think, release to at least a subset of possible bins and commodities that we're monitoring this fall. So I think we're going to be rolling this out pretty soon. And as we continue to get field data to validate the measurements that we're making here, we'll continue to increase the scope of our market for this product. So that's all I've got for now. Happy to answer any questions on the AGCO side of things. Yeah, thanks.
Yeah, thanks, Kurt. And I'm just calling back Colin and Jitendra. And I thought maybe we could start off with a little bit of a conversation among the four of us. Well, People in the audience are thinking about their questions and entering it in the chat function. And so while listening to each of your presentations, one thing came to mind, and bear with me, I'm a soil scientist, so I don't really work on grain bins. But Jitendra, you had that picture in the beginning that, it changed from, 6-meter high to 12-meter high. So you said the grain bin doubled in capacity. And one of the things I'm wondering, while listening to that is why would people not build 2 6-meter high grain bins rather than a 12-meter bin? And the reason why I asked that is because if you have spoilage in a 12-meter bin, you have a lot of damage. Maybe the likelihood that you have spoilage in both 6-meter bins is smaller. And so just wonder if you could enlighten me on that.
Yeah, for sure. I think that the answer is very simple. Rather than buying, 2 small cars, we buy 1 big car. Rather than, building 2 small homes, we build 1 big home. So it's the incremental cost of increasing the size of 1 bin is not that much. But if you were to build 2 bins, then they require more, setup costs in terms of, putting down a concrete pad and having 2 aeration systems and, having all the infrastructure, you'll have to have it twice as much. So that's the reason why increasing the size of 1 bin is makes more sense as opposed to having 2 bins. And when you say that the size of the bin has doubled, it's not the size, it's the diameter has doubled. So that means that the size of the bin, the capacity of the bin has actually increased by quite a bit, quite substantially.
Okay, yeah. And Jitendra, so in terms of risks, is the risk that you get spoilage in a bin, is it a function of size, or size hasn't to do with anything in terms of the risk of spoilage of your grain?
So in terms of looking at the spoilage that happens in a bin, there are quite a few parameters that need to be kept in mind. One is the initial moisture content of the commodity that's going in, the environmental conditions, your temperature, your relative humidity are going to play a role. In a bigger bin, and of course the time of storage, how long do you store a commodity inside the bin? So that again plays an important role, because the longer you store it, the chances of spoilage are higher. So there are a few parameters to keep in mind, but if you were looking at just the probability of spoilage in a bigger bin as opposed to a smaller bin, I think the answer lies in the fact that in a bigger bin, it's difficult to identify problems as opposed to a smaller bin. So that would be the main concern. And the gradients of temperature from the central core to the periphery of the grain mass is going to be much higher in a bigger bin. So it does yield itself to faster spoilage. That for sure is true.
And so hence the importance of the technology that all you three are working on, I think. That's so another question, Colin, and this is just a technical question. You mentioned that you were doing some coding, or you were mentioning the word code, and I just wonder what kind of language are you using in your coding, and is this something that is freely accessible, or is it something that only a few people actually can understand? I just wonder if you can comment on that, whether it's open source or specific individuals.
Oh yeah, so I mean, the code, we use many open source tools probably, but the code itself that does the inversion is definitely not open source. I mean, that's part of the intellectual property that is the glue of the company. But the languages we use are all over the place. So lots of it. There's so many for the core inversion. It's a parallelized C++ code. but all of the wrappers that work around it, are now written in Python. Originally, we just ran the C++ code, but many of most of the people have computer science backgrounds who are the software people at AGCO Winnipeg now have written most of their work in Python. I don't even know what the web is written in, the web service that the customers go see. I'm the backroom nerd, so I don't see the stuff that the customers see.
Yeah, thanks, Colin. So diversity of codes are being used in the research. So, curious, and again, I'm asking these questions because I don't work on grain bins, and so moisture was mentioned as a risk in terms of spoilage, and so I'm wondering what is the range of moisture that is safe, and I'm also wondering about what are other concerns in terms of risk to spoilage. Is temperature a factor? I'm just wondering if I look at the model that Kurt was presenting in his presentation, it certainly looked really nice. I just wonder what kind of parameters go in such a model.
Colin, you want to take that?
Sure, I can start. I mean, so the first part of your question of does the temperature matter? Yes. So there's the curves, many of which were generated out of Jitendra's lab at the University of Manitoba. They have safe storage curves as to how long you can store grain, and it's a factor. The most important factors are the temperature and the moisture content of the grain, which is a percent moisture of the total mass of the grain. And both of them, if either is really high, you're in trouble. And so you can tolerate a higher moisture content at a lower temperature.
Right. Yeah, so there's an interaction between those factors then.
Yeah, that's where my understanding ends, and I punt to Jitendra and Kurt.
Yeah, and that I think is an important factor why Canada has been so successful is because of the lower temperatures. Even if the moisture goes too high, our temperatures still remain quite low for the infestations to spread.
Right.
So that's a natural benefit that we have here up north.
Yeah, yeah. And the models that you are developing, are they empirical based or so you do experiments and you verify things, or are you using more sort of physics equation, chemistry equation that are quite fundamental?
I think this one's probably for me. So the models we're developing that map the electromagnetic properties of grain to those other physical properties I was talking about, like temperature and moisture and density, those we're building from experiments in the lab. There are some things that we can learn from fundamental physics, but grains are complicated structures, and packed grains together are complicated bulk materials, and so we have to rely on our in-lab experiments, and fundamental physics just doesn't have enough information about the detailed, let's say, molecular structures inside of a grain and how that all interacts with an electromagnetic field to give us an answer. So we need to rely on our empirical measurements here.
Yeah. Thank you. So I guess, how do you know that the models are working for, let's say, we have 100 grain bins and they are at different locations in the prairies, and you have that one model that you developed, or maybe several models, but that you develop based on empirical data at a certain location. And so how do you know that this model that you develop is applicable to a wide range of environments? And even if we're talking about the prairies, we do know that Alberta has slightly different temperatures and weather conditions than Manitoba, for example. So how would you know that one model that you developed works?
Well, we do this through testing. We have right now our system in a few dozen grain bins, and we are using these test sites as validation data to test the models we build in the lab to these different sites and see. We have scale tickets from when they load and unload those bins, and we can compare with the sampling that's done. For every truckload of grain that goes in and out of these bins, we have a moisture content and a test weight. We have a temperature cable that's inside of the bins that we can use that as another data point to compare with. And so we really need to do a lot of testing, and that's part of the struggle and why it takes us a long time to roll out this technology on a reliable commercial scale, right? We need to do these validations so that the customer can then trust what they're seeing from the GrainViz portal. Yeah. And so, we try to replicate the conditions as much as possible in the lab. We get samples from all over North America so far, and as we roll out to other countries, we'll be getting samples worldwide. And we test them under a variety of conditions in the lab, but then we also need to do those field validations to verify that, in fact, these are matching up with other measurements that can verify this.
Nice, yeah. And how do you engage people? How do you get people that say, "Oh yeah, I want to be part of that"? What's your strategy that the three of you are using?
Yeah, I'm not sure that's anyone on this conversation's responsibility at the company.
Oh.
It'd be part of the sales team who we direct that question to. But there are some producers and grain handlers who are more interested on being on the cutting edge of technology, and they're engaged in what's happening, and they're the sort of early adopter type customer. And in being an early adopter, we also allow them to get a discount on the product they're putting in, and maybe defer payment for a while on the system, so that they're providing us with meaningful data, and we're still providing them with interesting feedback and sort of an early adopter incentive.
Yeah. So with
sorry, can I just answer your question? So one of the core reasons, so there's two reasons why people are definitely interested in the technology. Is that the one is that producers grain is traded by weight. So if you can find a way to keep it closer to spoilage, like if you can sell 16% grain instead of 10% grain, you make more money, right? Now so everybody is excited about the idea of, hey, if I can keep my grain closer to the edge of being spoiled before I sell it, and I don't have to get rid of all that moisture, I'm going to make more money. And then the other one is that the current technologies, that the best technologies they have to monitor for spoilage can miss a lot of spoilage. They're sensors that hang from cables. They measure temperature and humidity local to that sensor. But the AGCO salesperson has had bins where they're monitoring them, where the bin has literally lit on fire 6 feet away from a temperature sensor, and the temperature sensor hasn't gone up yet. But over here, the grain has started to spontaneously combust inside the bin.
Yeah. Thanks, Colin. Thanks for that extra information there. That's great. I do get notification that we actually have a range of questions. So I am going to turn it over to Crystal, and I just wonder if Crystal can remind those that still haven't asked questions but would like to, if you just can remind people how to do that.
Thanks, Anamika. Yeah, we've had some interactions on slido.com. So if you haven't gone over there yet, if you have a second screen or maybe your phone, you can slide over there, and #storedgrain is our event code. I did ask at the start, where are people watching from? So we did have a few responses. A couple said that they are watching right from campus, which is great. And then another person said they're watching at 303 Main Street, which I think is probably one of our federal buildings downtown. So the first question that was posed is, are the grains stored in the farm bins insured for fire or weather damage?
I don't know.
Do you know that?
No, I don't know the answer to that offhand. I mean, GrainViz installation at a bin, I think it's still up to the consumer, the end user of the technology, to decide how to insure their bins. I don't think at this time we have, any incentive from an insurance perspective to monitor this grain. I can definitely see it going that way, right? I mean, if you have full monitoring of every bushel of grain in your grain bin, you can see that that might, insurance companies may eventually decide to incentivize that. There's less risk there. But at this time, I think it's just, up to the end user right now, the same as always.
Okay. And Justin Bouchard is asking, does this work the same for all types of grain? I know canola can be difficult to store due to the oil content as opposed to wheat.
Right, yeah. So canola is also in development for monitoring. Like I said, we have to go through extensive testing on each of the commodities that we monitor. But yes, we've had actually a lot of success in monitoring canola. And I know there are some risks associated with canola because of the high oil content. But yeah, we plan to very shortly be moving into canola monitoring as well.
Yeah,
just to add on to that, we're looking for preconditions for spoilage. So preconditions for spoilage would be accumulation of moisture in small pockets, and that is irrespective of what crop is in there. The parameters of imaging may tweak based on the crop that goes in, but the preconditions more or less remain the same. You observe, that there is an accumulation of moisture. That something's going to go wrong sooner or later. Sorry, Colin, I cut you off. You were to say something. Go ahead.
Yeah, no problem. I was just going to say, in terms of the science question, yes, it works for all types of grain. It's just that there's, to make it a commercial product and have it work on thousands of bins reliably, you've got to get a lot more data, and that's what Kurt works on. We've had people, where it does break down is we've had people ask us if we could install it to monitor potatoes. Potatoes have such a high moisture content that the electromagnetic signals don't penetrate far enough on a potato. So that's where it breaks down, but that's not a grain. Basically, anything that goes in a bin is probably low enough moisture content that we could do it.
Sounds good. Is there any potential to tweak this technology to capture the causes of moisture buildup before it starts? I'm thinking of insect activity and mold growth.
Once again, as I said, that we're looking at preconditions. So anytime, you have accumulation of, say, fines in a bin, that is going to attract a lot of insects there, which are going to produce, more moisture because, they respire. And that is how you can catch that. You may not be able to tell that there are insects, but you can tell that as a consequence of some biological activity, there is a pocket of high moisture there. And that way you can catch, insect growth, you can catch mold growth in a particular section or, a portion of the bin.
Awesome.
I hope that answers the question.
I think it did. The next question, and this person pre-qualifies their question by saying, I am not a farmer or a scientist. Can you compare this to other types of sensors that are used in grain bins?
I mean, the other primary kind of sensor that's used to monitor grain bins are the temperature and humidity cables that they hang from the roof. And so, as Colin mentioned, those sensors are very localized to the grain that's directly around the sensor. Those sensors have been around for a long time. There's a lot of good data models to support them. But GrainViz is something that is, entirely different than that. Because we're monitoring grain through the entirety of the bin. Those electromagnetic waves go through every grain that is in the bin. It gets sampled, and so that's one of the main differences that GrainViz can offer is it's global instead of a local measurement of your grain.
Fantastic. Next question: what solutions exist to treat the grains in the bins when the monitoring system identifies a hot spot deep in a bin?
So, maybe I can take that one. Most bins, especially the bigger they get, they have fans with a false bottom that allows air to go through. So the first step would be to turn on your fans to try and blow air through and dry out that pocket of grain, or lower the temperature, lower the moisture, and make it into safe storage again. And if that doesn't work, you might have to draw the grain out. And it could be as simple as you just cycle the grain back into the same bin, which, if you're a farmer, might be quite difficult, but a commercial producer just turns on the machines and it'll flip it back into the bin. And that might be enough to break up that spot, spread the moisture around, and it's no longer an issue.
This is just a side question from me. Is spontaneous combustion a concern with hot spots?
I didn't believe it when I started this, but I've now seen pictures. One of the first salespeople at 151 had a picture of a bin on fire just south of Winnipeg in LaSalle. And yes, they do start on fire.
Especially with canola and corn, those types of high oil crops, you see that the chances of fire are actually much more.
All right. This sounds like a question that maybe has been answered. Will your monitoring system detect insects in the bins?
Not directly, but indirectly, again, as there is more biological activity when there's accumulation of the moist grain mass, and it could be because of insect activity. So that's what we can catch.
Okay, this might be one for Kurt. Tell me how you convince farmers to monitor consistently and electronically.
Again, I would like to defer the question to the sales team if possible. I saw myself as a scientist and not a salesperson, so I try not to convince anyone of anything. I don't really think there's a lot of data to support necessarily. So I mean, I think that this is a great product that can, like as I said, we can monitor everything that's in the bin. The farmer, of course, has to perform the cost benefit analysis to putting in our system versus rolling the dice and not monitoring it. And luckily, it's not my job to convince them to go one way or the other. My job is to provide the data to back it up and to provide good models to support that what we're showing the farmer is indeed the truth about their grain.
So Kurt, can I ask a question? I know you're not a salesperson, and I mean I could contact the salespeople, I suppose, but what would be the cost of a system like this? Let's say perfect world, everything is set up and ready to go for large scale delivery, so to speak, in Canada and beyond. Like what would a farmer look at in a cost per year, or one time cost, or a cost per month?
Yeah, that's a great question. And in preparation for this talk, I asked the same question to the sales team. And the answer I got back was not very satisfying. It's that, being in a pre-commercial release, we don't have pricing nailed down yet. So I'm actually not able to give you any numbers on the pricing right now. What I can tell you is that our target market is the sort of larger scale, more advanced producer and the commercial grain handling site. So it'll likely be, priced accordingly to that. GrainViz makes sense in larger bins. It makes sense in smaller bins when there is a high value commodity that's being monitored, where being able to store a few more points of moisture might be worth it from a dollars perspective, or the risk might be very high for that particular commodity that needs to be monitored. Or like I said, for high throughput applications where inventory management is a really big concern. But other than that, I can't say much about pricing in terms of numbers right now. I'm sorry.
So we have to re-invite you in a couple of years then.
Well, hopefully not years. Hopefully it's on months.
months.
Yeah.
Next week.
The sales team.
Yeah.
And Annemieke, I think you preempted the next question, but I'll just ask it. It says, is the cost of this technology competitive? How difficult will it be to convince potential customers who may be accustomed to temperature sensor costs?
Right. Yeah. And again, for smaller bins, to put a single temperature humidity cable in that bin, we are going to cost more than that, certainly. For some of the larger scale bins where they're hanging, multiple 6 or 25 cables I've seen into a grain bin, then it starts to make sense to maybe put GrainViz in instead from a financial perspective alone.
Awesome. Paul Bullock sort of is answering a previous question. He said insurance is usually carried by both farmers and grain companies. The next question is from Martin, and I suspect that this might be our Dean Martin. He asked 2 questions. What is the spatial resolution of the technique? And can you integrate grain handling infrastructure with measurements on grain flow through coupled to dryer moisturizer equipment to hit specific moisture content? Who would like to take that on?
I'll get Colin the first one. Yeah.
Yeah, I'll try the first one. So the spatial resolution varies with the size of the bin. So in order to get electromagnetic signal from one antenna to another at a sufficient level that we need, we have to drop the frequency for bigger bins. And in that, dropping the frequency means the resolution goes down. So in Jitendra's bins, in Jitendra's bins, which are, I think, 4-meter diameter bins that are in his lab, the resolution there is something on the order of maybe 2 or 3 liters of volume is one cell. Whereas in the biggest bins that have been installed in at 100, they're 42 meters, 135 foot diameter bins. Now the resolution is you're talking a region that's more like maybe through like it scales with the volume of the bin, not necessarily distance. So your resolution might be something on the order of 3 or 4 bushels. So that would be maybe 100 liters, call it, on a million bushel bin. So it's still very small as a percentage of the bin. Maybe for the second question, maybe I'll send it back to Kurt as to where we are with integrating the moisture equipment.
Sure, yeah. Sort of as I alluded to before, GrainViz is one piece of that larger puzzle that we want to address. Right now, there's no integration of GrainViz with other grain handling equipment or other inventory tracking equipment, with the exception that GrainViz has the ability to control the fans that are usually, as Colin mentioned, in the floor of a bin. And so we have that one integration right now, but the plans are big for the future to integrate GrainViz monitoring technology with other feedback and critical control points that we see throughout the grain handling life cycle. So, I'm very excited about where this is going to go, but right now it's a little bit more in the sandbox.
And I think, Colin, you may have touched on this in your previous answer. What is the largest size of bin that this technology can work on?
Yeah, I think GSI is currently working on a 2 million bushel bin. Kurt might know more, but there's no limit. We make bigger antennas and we drop the frequency of operation, so the resolution will drop. But the short answer is no limit, but I don't know, Kurt, in the specifics.
No, that's right. I mean, you'll have to wash my mouth out with soap for speaking American here, but 156-foot grain bin is the largest that GSI offers right now, and even those are not very common. It's hard to get the economy of scale that large with the risk involved. So they offer up to a 156-foot grain bin, which we can in fact monitor. Most of the installations so far have been 135 and below. 80-foot grain bins are more common yet. So but that's not the issue for this technology in terms of size. So we can go up to 156 workably right now.
Awesome. Harry Siemens has a couple of points he's just asking. Some systems give a false sense of security to farmers. How to avoid that? And then he said, is it an add-on or best installed with the bin?
Sure, I could try to address these. I think, in terms of the false sense of security, you can see that as potentially being a symptom of cable monitoring because, again, you're only monitoring a very small percentage of the grain in the bin. And I think GrainViz does, in fact, help to avoid that by monitoring, the entirety of the grain contained within the bin. You'll have to give me a bit more context to your question if it's something outside of that. To address your second question, it is best installed when the bin is first being built, but we can retrofit bins as well. The system is designed to be able to accommodate both new installs and retrofit of existing bins.
Awesome. That's it for the questions from Slido. Anamika, did you have any final questions that you'd like to ask?
Well, I know it's almost time, but I do have a question that I was thinking about when there was an interaction with the audience. I wonder what the sensitivity is. So the theme moisture content, moisture change came up quite often during the conversation, and in terms of the sensitivity of the equipment, are we, able to measure, change that is 1% or 0.1% or 0.0.0.01% change in moisture?
Yeah, great question. Right now, our target accuracy is 0.8% moisture content by weight. Grain cables typically are spec'd at a little bit better than that, 0.5%. But of course, you give up, the statistical undersampling you get from cables compared to the, full bin monitoring. So we're targeting 0.8% right now. I believe that as this technology develops, it has the potential to improve significantly, to get even better than where cables are. But that's where things are at right now.
Great. Crystal, is there one more question that came up that we can squeeze in before we go?
Sure. Actually, there's two maybe that I could just throw at you real quick. One is, are there any health implications with increasing the size of the antenna? And would this be able to be modified to accommodate piles of grain or rectangular bunkers?
So I started in the medical imaging, I've looked at the given safety codes for the amount of electromagnetic energy, and the short answer for health concerns is no, there's none. I mean, we just don't radiate enough power to come anywhere close to what is the safety code 6 is what it's called in Canada anyway, of what you're allowed to radiate and what's safe and what's not. And it purely has to do with the heating, just like you can heat things up too much, and we're radiating inside of a metal bin, so it just, all of the energy stays in, and then even then the amount of energy is still much lower than safety code 6 allows.
I can add to that as well. In our lab, initially there was a concern that there may be some radiation type of issue, so we did some measurements, and it was so low that you could hardly pick it up.
We couldn't. If you were outside the bin, you could the electromagnetic meter couldn't tell if the power was on or off to our antennas, because the bin contains the energy.
Awesome. And that last question was, can you do it? Can you modify it to accommodate a pile of grain or a rectangular bunker?
Yeah, so right now we rely on a metallic grain bin. The reflections of the electromagnetic field inside the bin are part of how this system functions right now. But we are working on additional monitoring technology to accommodate those other configurations.
Great. Well, I really enjoyed this presentation. It's something, learned something new, and I appreciate that. And I would like to thank you, Kurt, Colin, and Jitendra for all your time and presenting on your exciting research and opportunities. So for the audience, we have at least one more faculty conversation scheduled soon. And you can mark your calendars for Wednesday, April 14th, when we will be joined by Dr. Ryan Cardwell, who is in the Department of Agribusiness and Agricultural Economics at the University of Manitoba. And Ryan will be joined by his colleagues, Dr. Jill Hobbs, who is at the University of Saskatchewan, and Dr. Alan Kerr, who is at the University of Guelph. And they will be presenting on a very topical area, which is an updated economic analysis of the impact of COVID-19 on Canadian agricultural and food science sectors. So please watch for the updates on our faculty conversation series and other things. You can visit makemanitoba.ca, which is indicated on your screen. And if you haven't done so already, you can also sign up to receive the Ag e-News, and the Ag e-News email address to sign up is also indicated on your screen. So with that, thank you so much again for joining us today. I hope you enjoyed it as much as I did, and we're looking forward to seeing you back on April 14th. So good afternoon and thank you.
Thank you, Anamika.
Thank you, Anamika. Thanks for having us.
Thank you.
Thanks, guys.
It was a pleasure. Thanks.
Bye-bye.